Hello everyone. Today we are going to delve into the world of monitoring and observability. This is all about building visibility into distributed systems. We will explore how to gain insights into the health and performance of complex software environments. The key components we will focus on are metrics, logging, and tracing, which are the three pillars of observability. Each of these plays a vital role in understanding what's happening inside your systems. So, what exactly is observability? Well, it is the ability to understand the internal state of a system by examining its external outputs. Instead of just knowing that something is wrong, observability helps you understand why it's wrong. This is crucial for debugging unknown problems and gaining a deep understanding of system behavior. With observability, you can ask questions about your system and get answers based on the data it produces. Let's start with metrics. Metrics are numerical data, time series data that measures system performance and behavior over time. These are typically aggregated values that you can use to monitor trends and set up alerts. For example, you can track the number of requests your server receives per minute or the average response time. Here is a quick example in Python of using metrics. First, we increment a counter metric to track request counts. Second, we set a gauge metric to record memory usage, for instance 85.2%. And third, we observe the response time with a histogram metric, recording a value of 0.250 seconds. Now let's look at logging. Logging involves creating structured records of events that occur within a system at specific points in time. These event records provide context details and are invaluable for error investigation and creating audit trails. Proper logging helps you trace the sequence of events leading to an issue. Here is another example in Python of implementing logging. First, we get a logger instance. Then we log messages at different levels, such as info for successful user logins, warning for high memory usage, and error for failed database connections. Next up is tracing. Tracing tracks the path of requests as they flow through distributed systems and services. It helps you understand service dependencies and analyze latency, making it easier to identify bottlenecks. With tracing, you can follow a request from start to finish, no matter how many services it touches. Here is an example in Python of using tracing with OpenTelemetry. First, we get a tracer instance. Then we start a new span called process order. Inside this span, we can set attributes, such as the order identification, to add more context to the trace. Let's compare these three pillars side by side. Metrics provide time series data, aggregated values, and are great for performance monitoring and setting up alerts and service level agreements. Logging gives you event records, context details, and helps with error investigation and audit trails. Tracing allows you to follow the request flow, understand service dependencies, analyze latency, and identify bottlenecks. Each pillar offers a unique perspective, and combining them provides a comprehensive view of your system. Now, let's discuss how to implement observability in your systems. A good starting point is with metrics. They're relatively easy to set up and give you immediate insights into performance. Next, add structured logging to capture detailed event data. Then, implement distributed tracing to track requests across services. Finally, correlate all three pillars to get a holistic view of your system's behavior. Here are some popular tools for each pillar. For metrics, Prometheus and Grafana. For logging, ELK Stack and Fluent. And for tracing, Jaeger and Zipkin. Lastly, let's cover some best practices for observability. Here are some do's. Use consistent naming conventions, implement structured logging, set up proper alerting thresholds, and correlate data across pillars. Here are some don'ts. Avoid over-instrumenting everything, don't ignore data retention policies, never log sensitive information, and avoid creating noise with false alerts. By following these best practices, you can ensure that your observability efforts are effective and provide valuable insights. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.